Okay, for this next one, it looks a little confusing, but let's just boil it down to something simple. This top denominator is a distraction because look, it doesn't matter how much I shift this n minus 1. I could put n minus 3 and it wouldn't change the fact that this is just making my series either positive or negative at a certain point. And so this is a telltale sign of alternating series test. And so immediately I want to show that by the alternating series test, that this thing is either convergent or divergent. Okay. Okay. So let's see. By alternating series test, I know I have to check that the limit of an, eliminate this, my new an is equal to 1 over root n minus 2. So this is my um, new sequence that I define. Series that I define. I just took away the negative part. So limit of an as an goes to infinity is the limit, and I want to show that this is equal to 0. And the second thing is I want to show that an is decreasing. So how do we show this? Let's show the first one. First condition is simple. Let's just take the limit. So if I take the limit of n as n goes to infinity of 1 over root n minus 2, notice that take the square root of infinity, it is still super big. And so this is 1, a really small number, over a really large number. And so I'm basically saying that this is essentially equal to 0. Okay, so first condition is met. Now let's check if the second condition is met. So an is decreasing is really asking on the interval that we define the series from n is equal to 5 to infinity. Is this series decreasing? So let's check the derivative. 1 over root n minus 2, this is just, this should just be a chain, should be a chain rule derivative. So if I take the derivative of this, I rewrite this as this, do a chain rule, so 1 root n minus 2 times 1/2 n minus 1/2. Notice that this 2, so long as you plug in positive numbers, well, we are always plugging in positive numbers because the domain is restricted. This will always be positive. And this, so we care more about this. We care more about the n behavior. So if n is equal to maybe like 6, it's already bigger than 2. N just had to be bigger than 4 in order for this to be all decreasing. And that's true because we defined the series starting from 5. So actually, if I set n is equal to 5, it would be root 5 minus 2, which is negative for sure. But more importantly, this negative tells me that this derivative is always negative, and so that means it's always decreasing. And so the second condition is met. So that means that my series is converging.